Hi guys, today we're going to learn more about the chain rule. Let's look at this example. Find the second derivative of f of x is equal to 4 times x squared minus 5 to the power of 3. So what are you going to do? Well, since we want the second derivative, let's find the first derivative first. So the first derivative of this equation, we do need to use the chain rule. It's going to be 12. Okay, and then it's going to be x to the power of 2 minus 5, close it, and then to the power of 2 times, you use the chain rule here, 2x. Okay, so at this point you are like, okay, so this I can simplify it as 24x times x squared minus 5, close it, x squared. So to get the second derivative over here, second derivative, this is the notation that we use to basically lines here. Okay, so the second derivative, you need to do a product rule. So we have the first one, which is 24x, times the derivative of the second one, which you know that it's going to be 2 times x squared minus 5 to the power of 1, times the derivative of the inside, which is 2x. After that, since we have the power rule, close it, plus is going to be this guy, x squared minus 5 squared, times the derivative of the 24x, which you know that it's going to be 24. Okay, so that's what we have so far. Now I'm going to try to simplify it a little bit so it looks better. So over here what we have is that 24 times 2 times 2 times 24. So that one I have, oh no, 24 times 2 times 2. Okay, so that one I do have that it's going to be 96. Okay, and the 2x's is x squared. Then you have the x squared minus 5 to the power of 1. And then on the other side I just have the 24 over here. Okay, and then I have the x squared minus 5 and to the power of 2. And that's pretty much what we have for this equation. You can simplify it a little bit more, but it's not needed. For example, what we want is to find the points where f has an horizontal tangent line. In order to do that, we need to find when the derivative of this function is equal to 0. With that being said, what we're going to do obviously is we're going to take the derivative of this equation. As you can see, this is going to be a ratio, therefore my best shot is taking the quotient rule. So you have 2x minus 1 to the power of 1/2 times the derivative of the top, which is 1 minus, and then you have the top times the derivative, that it's 1/2 times 2x minus 1 of the bottom, okay, to the power of 1/2 times the derivative of the inside, and you are done with the top. Now for the bottom, what you have here is you have this equation square, therefore you just have 2x minus 1. Okay, at this point, remember, we want to equalize all of this to 0, so it's not as simple. So my recommendation for you is to factor out something, and in this case I'm going to factor out the 2x minus 1. Okay, so I'm going to the 2x minus 1 to the power of negative 1/2. If I factor out that one, when I take it out from this term, I just basically what I have left is the 2x minus 1. Okay, think it backwards. When I add this one to this one, I get this one. Okay, so that's why we have this equation. In addition, you see that these two, they cancel. So when I remove this one, well, I take it out, I just have left my negative x. So this is what we have on the top when I factor out the 2x minus 1 to the power of negative 1/2, and I have this. Okay, so at this point what we can do is we combine these two because they are the same thing, let's say. So what you have here is you have and you combine this part, so you have x minus 1 at the top, and then when you cancel, you have that it's going to be 2x minus 1, and this is going to be to the power of 3 over 2. Okay, so this one looks much better. So when we equalize this to 0, remember that was our goal, when we equalize this to 0, okay, what do you have? Well, here you have pretty much only one situation, x minus 1 is equal to 0. Okay, so that's when that's going on. So you have that x is equal to 1. Therefore, what can you conclude? Thus, I want to find f of 1. F in the original, you know that that's going to be 1. Therefore, what do you have? Therefore, what we have is that f has an horizontal tangent line, okay, at the point 1, 1. Okay, so that's what we have for this problem. Please remember to conclude, and when they tell you point, the expectation is that you actually have a point. The next problem that we have over here, we want to find g prime of x, given that gx is equal to f of 2x to the power of 3. So here we just need to use the chain rule. So you have that g prime of x is going to be equal to, use the formula for the chain rule, f prime of the situation times the derivative of the inside, which is 6x squared, and that's as much as we can do with the information provided. Okay, and that's it for this problem. For this problem, what we have is that we need to use the graphs of g and f to find the following if they exist. The first part of the problem tells you that h of x is equal to f of x times g of x, and they want you to find h prime of 1. H prime of 1, you can find it via the product rule because this is a product. Therefore, you have f of 1 times g prime of 1 plus g of 1 times f prime of 1. With this being said, what you have is you can find pretty much f of 1. So you go, this is your f, so f of 1 is 3. Then you have g prime of 1. G prime of 1 is the derivative or the slope, okay, at 1. And the slope here, you can see that it's going to be negative 1. Okay, that's the slope that you have here. Plus, and then you have that it's g of 1, which is 3. And then we have that it's f prime of 1, which is going to be the slope of f at 1, which is this one, okay, which we know that it's going to be 4 divided by 2, that's 2, okay. Then you combine your situation there, and it's going to be negative 3 plus 6, which you know that that's going to be equal to 3, okay. So for the next one that we have, you can see that in this case, we have that k is formed by the ratio of f of x divided by g of x, meaning in this situation, since I want k prime of 6, I want to use the quotient rule. So k prime of 6 is going to be equal to the bottom one times the derivative of the top one minus the top one times the derivative of the bottom one divided by the bottom one square. Okay, so let's get my ruler here. So this is what you have, right? So in this situation, what we're going to find is we're going to find the value of g of 6. G of 6, you have that it's 1, 2, 3, 4, 5, 6, and I'm just going to mark it here. So g of 6 is going to be 2. Okay, then you have that f prime of 6 is going to be the slope of f at 6, meaning I want this part. Okay, so obviously you see that that's negative 1/2 minus, and then f of 6, that one is f of 6, no, that's g, so this is f. Okay, that's going to be 4, and then last but not least, on the top we want g prime of 6, which is the derivative at 6, which you know that it's going down. It's going down, basically negative 2 is going to be your slope. Okay, and this is going to be divided by g of 6, that we already know that it's 2 squared. Okay, so we have this equation over here. So what I have is that k prime of 6 is going to be equal to this cancel, so that's a negative 1, this is a positive 8, so that's a 7, divided by 2 squared is 4. Okay, and that's going to be it for B. So for part C, what we have is that P prime of 6 is going to be basically we need to use the chain rule because P is defined as f of g of x. Therefore, P prime of 6 is going to be f prime of g of 6 times g prime of 6. With this being said, from the previous problem, what we have is that g of 6, it was equal to 2, and then we know that g prime of 6, it was equal to negative 2. Okay? So at this point, what we're going to do is we're going to find the slope of f at 2. So we go to your graph, and then you're all happy with 2, and then you see that there's a sharp turn here. Therefore, it's not differentiable at 2. So what can we conclude here? Well, obviously you are like, this is not cool. So you have that it does not exist because it's not differentiable. And you can say here it's not differentiable at specifically f not differentiable at x equals 2. Okay? Why? Because there is a sharp turn, and you know that that's a no-no for taking derivatives. So for the last piece of the problem, again, you have the chain rule because we have that t of x is defined as g of f of x, and we want to find t prime of 7. So to find t prime of 7, what we need to find is g prime of f of 7 times f prime of 7. Meaning the first thing that I want to find is the f of 7. F of 7 here is 1, 2, 3, 4, 5, 6, 7, and your f is over here, so that one is kind of like a 3.5, you can see it. So I can find g prime of 3.5 times the slope of f at 7. So the slope of f at 7 is going to be pretty much this chunk, which you do know that that is going to be negative 1/2, okay? So we have this. After that, we want the slope of g at 3.5, okay? So 1, 2, 3, and 0.5 is going to be this piece that it's increasing, okay? That one is increasing by 2/3, okay? So you have that t prime of 7 is equal to 2/3 times negative 1/2. Okay, and after that you cancel out the 2's, having negative 1/3, and that's pretty much it for this problem. I hope that you find this video helpful. Bye!